Hi everyone. TuneIn is a framework designed and implemented for education using dynamic difficulty adjustment based on deep reinforcement learning and mathematical approach. The research is conducted at Deakin University, Australia by Dr. Alessio Bonti and his assistants. To begin with, education, personal development, and overall learning has vastly changed over years as a result of historic events, methodologies, and technologies. As students first and then educators, we have only seen slight changes in delivery of education content, with the most accepted model being one system fits all. We have seen contents and delivery mediums, but little about differentiating or personalizing the education experience. We challenge this traditional model by implementing an adaptive training framework based on AI techniques through a dynamic difficulty adjustment agent. We have conducted a limited sample size experiment to prove that personalized content always allows learners to achieve more than the static model. As we move towards education as a commodity that we can access across any medium, more questions arise whether or not standards can be maintained to engage with ever increasing student population. With these critical findings, how can we With these critical findings, how can we guarantee quality and also an exceptional student experience? Under this pressure, the ideals of young educators fall back into providing minimal required standards or the comfortable one method fits all. This has motivated us to go uh, beyond these thoughts, find ways to make people's lives more rewarding and educators' role simpler by applying an adaptive framework that allows that only requires to be developed once and updated less. One key feature was to implement an assessment-based system called flow theory. Flow is a state of mind where the user's engagement and learning are maximized, and that happens when the task ahead is well adjusted difficulty for the user. Not seems too easy, not too difficult. This theory is vastly used in creating artificial intelligence for video games to keep the player engaged, making the game neither too difficult nor too easy. We adapt this to allow us to create a personalized experience for each student. Using this method, students always face the task ahead for the right difficulty. As we assume all the students are not are different and learn at a different pace, this way students who are slower than others do not face difficult tasks that make them drop out. And those who are faster are not bored because the tasks are too easy for them. We believe one of the most well-known characteristics of a game is freedom to fail. This approach reduces the fear of failing in learners and also results in positive student engagement. The concept of gamification in education is what allows us to adjust learning activities based on the progress of individual learners. This is called dynamic difficulty adjustment system. The DDA system has focused majorly on multiplayer games. However, the research is now being done to apply DDA to serious games and training procedures. Most of the difficulty adjustment resolves around the modification of specific parameters in game scenarios to ensure that the player do not get bored or frustrated while playing the game. The aim of this research is to apply DDA on pure education platform. To run the test, we have selected a pool of 500 questions and problems from a linear algebra class divided into 5 levels of difficulties. The test consists of a pool of 20 questions with a time limit of 2 minutes for each question. Every time a student takes a test, the app chooses behind the scene whether to use DDA system or not. The app in DDA mode presents questions of varying difficulties, depending on the student's current level. While the DDA mechanism is not chosen, the question is generated using a pattern of from 1 to 5. The level is chosen randomly with an equal distribution of different difficulty to prevent the students from facing a test with only hard questions or easy questions. The result will be randomly selected for 4 questions per level. To run the test and evaluate whether DDA mode is more significant than the random picking of questions, we use two different models of DDA. A similar one based on mathematical operations called Math DDA, and the one with reinforcement learning. Here's an example of how DDA is applied to maximize the final outcome of the test. In this research, our initial aim is to find a DDA system if a DDA system improves overall student performance, especially in the amount of content observed. The second aim was to find how well a DDA student performed compared to a student undertaking a standard test. The work was compared to a standard method called Math DDA. In Math DDA, the level difficulty always starts at 1. It is updated depending on whether the last question was answered correctly or not. Each correct answer increases the updated level by 1/3, while the mistakes decreases it by 1/6. Two numbers differ, reflecting that a wrong answer is not intended to be a punishment. The proposed method, RLDDA, is a reinforcement learning agent based on feed-forward neural network. A custom reward function is constructed to extract the best outcome of the student. The goal of this method is to optimize policies that maximize the reward function. The application flow is simplified to allow users from different domains to comprehend the end-to-end solution. We worked with a sample of 99 students who completed their assignments equally split into 3 groups. Every cluster of 33 students performed the test similarly with the same time constraint, differing only by the algorithm that picked the questions. As a result show, RLDDA based students were able to score high compared to the other methods. We also discovered that average time spent per question for RLDDA backed student is slightly low compared to the other random approaches. To conclude, the few elements that we have used and the assumptions we have brought forward were proven correct within the limitations of our experiment. We strongly believe that physiological factors are the key to keep students focused on the test and make them confident about their knowledge. Thank you.